Good morning, good afternoon, and good evening. Dear authors and distinguished guests, welcome to Technical Session 2B. I'm Sanskriti and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Conference on Information Communication Technology for Intelligent Systems, ICTIS 2026, being hosted in Bangkok, Thailand. This 11th edition is being conducted in a hybrid mode. The physical conference will take place tomorrow in Bangkok, while the virtual sessions are being conducted via Zoom from 9th to 11th April 2026. I hope you find today's session insightful, engaging, and intellectually enriching. In this session, we have 10 presentations. Each presenter will have 10 minutes for presentation, followed by 2 minutes for Q&A. A gentle reminder will be raised at the 9-minute mark. All participants are requested to remain connected until the closing remarks. Any queries or updates, please use the chat box. Now, before we begin, I would like to introduce the session chair for this session. We have Dr. Vipin Khatri, who is a professor at the Department of Computer Science and Engineering in Purnima University in Jaipur, India. He's an experienced academic with research expertise in AI, deepfake detection, and natural language processing. Welcome, sir. Would you please like to share a few words with us?
Good morning and thank you. Hello.
Yes, sir.
Should I introduce myself?
Yes, sir, please.
Okay. Good morning, everyone. I am Dr. Vipin Khatri, professor in FC Department, Purnima University, Jaipur, India. And I would like to say that basically the research paper in conference presentation is very good step for beginning of the research. It creates a path for every researcher to move forward. So everyone has to make more and more effort in writing a conference paper. Thank you.
Thank you for the words, sir. Now let's start with the presentations. First, we have Dipali Nevaskar presenting AI-based post-event surveillance system. Dipali, are you present? Ms. Dipali, are you present with us here right now? Okay, we'll be moving on to the next presentation. We have Lavanya K presenting an intelligent cyber attack detection and mitigation framework using deep clockwork recurrent neural network and deep Q networks.
Good morning, madam. Hello.
Hello.
Am I audible, madam?
Yes, you're audible.
I'm Dipali Nevaskar with paper ID 235.
Okay, all right. Please go on ahead. Just be quick as we have already just now. Please start your presentation.
Okay.
यहाँ पे देखना होता है।
Just a minute, madam.
अटेंडेंस पे साइन हो जाएंगे।
Madam, is my screen visible?
Yes.
Okay. Yeah. Good morning, everyone. I'm Deepali Nevaskar, and on behalf of all my team members, I'm presenting our review work entitled AI-based post-event surveillance system with paper ID 235. This work is primarily conceptual and research-based study developed through analysis of multiple review papers, and finally we proposed a system which can be implemented. This would be the flow for today's presentation. Moving ahead, today surveillance systems are widely deployed across homes, public areas, and organizations, generating massive volumes of video data daily. However, manual analysis of this data is time consuming, inefficient, and prone to human error. So our work focuses on post-event surveillance, where recorded footage is analyzed after an incident or to identify suspects and reconstruct the event. With advancements in AI and deep learning, automated systems can now detect faces, analyze behavior, and identify suspicious activities more efficiently than the traditional methods. The motivation behind this work comes from increasing security threats and theft incidents. Human monitoring has limitations such as fatigue and inconsistency, whereas AI-based systems can provide continuous and reliable surveillance. Additionally, combining biometric features like face and gait with behavioral analysis can significantly improve the identification accuracy, as well as it will reduce the false alarm also. So moving ahead with the problem statement, we have addressed there is a lack of integrated and efficient system that can accurately analyze the surveillance footage. Existing systems often focus on single aspect, but our idea is to combine face recognition, gait analysis, as well as behavioral analysis. All these are combined to improve the performance across real world conditions. So our key objectives are to detect and analyze criminal activities using multiple AI techniques, to generate detailed reports with timestamps and identified individuals, to reduce false positives through integrated analysis. So the scope of our work is limited to post-event video analysis, meaning the system analyzes stored footage rather than real-time streams right now. Also, as this is a proposed system, its performance may vary depending upon the real world situations. Now, with the literature survey, we have conducted an extensive literature survey covering face recognition, gait analysis, behavior detection systems, etc. Some key observations include face recognition models like TB, CNN achieve high accuracy but struggle with real-world variations like blur and occlusion. Gait recognition has reached accuracy levels above 99, but it is affected by environmental conditions and spoofing risks. Behavior detection systems still face challenges in detecting complex and subtle activities. From these studies, we identified a major research gap, like most systems focus on individual techniques rather than combined multimodal approach. So we have basically targeted multimodal approach for this detection. So the problems in existing system I may specify. Based on our analysis, the major limitations are reduced accuracy due to environmental factors, privacy concerns in surveillance systems, high false positives and false negatives, there is difficulty in detecting subtle and complex behaviors. So these limitations highlight the need for more integrated and intelligent systems. So we have proposed our system, which is AI-based post-event surveillance framework. It aims to analyze stored video footage, identify suspects using face and gait recognition, detect suspicious activities using behavioral analysis, and generate structured reports for investigation along with timestamp. It is important to note that this is a proposed model based on literature insight and has not been implemented completely yet. So this shows the system architecture, which consists of multiple modules for video pre-processing, face detection, recognition, gait analysis, behavior analysis, report generation, etc. So all these components work together to provide a comprehensive analysis of surveillance footage. The workflow for proposed system includes pre-processing video and detecting individuals, applying CNN-based face recognition, performing gait analysis using sequence models like RNN and LSTM, which is long short-term memory, detecting suspicious behavior using spatiotemporal CNN, combining all outputs using an ensemble approach, and generating detailed reports with timestamp. So this multi-layered approach will help in improving accuracy as well as it will reduce the false detections. So our study presents conceptual framework for AI-based post-event surveillance system. By integrating multiple AI techniques, the system has potential to improve investigation efficiency, reduce manual effort, enhance security outcomes, and future work will focus on practical implementation, real-world testing, and optimization of the proposed models. These are the references, key references we have referred for this study and finding the research gap. Thank you so much.
Good morning, researcher.
Yeah, good
And
morning, sir.
I would like to suggest you one thing and very important in your research journey,
Okay.
that you have done a literature review
Yes,
type,
sir.
but the deep study is required for any research, any survey paper.
Yes, sir.
And this type of paper is no use in your research life. No one will recognize you.
Okay.
You have to set a benchmark in such a way that your paper will be referenced by many people, many researchers, other researchers.
Okay.
So, and one more thing, you should write the implementation based paper.
Yes, sir.
This
So
scenario,
implementation is going on actually, and we have analyzed different
but
algorithms also
no,
for
just listen to me.
sorry.
Just listen to me. Because whenever you say something, you have to prove
Okay.
something. Only just proposing a thing, it's not sufficient for the research validity.
Okay.
My suggestion is that when you proposing a something, you have to implement some way.
Yes.
Then your credibility will be recognized. Otherwise, when you go for a job, then definitely everyone see your CV with your research paper.
Yes.
And the weightage of research paper is very important in your future life. So in my suggestion is that please write some effective paper, implementation based paper. And if you want to write a survey paper, then you have to do some deep study.
Okay.
Generalized statement, generalized view, this model, so and so. So this is not sufficient for any researcher for their future journey, better journey.
Yes.
So now everything is okay, but
Yes, sir.
please take care of this. Hai na? Thank you. Okay.
Yes, sure, sir.
Thank you, Dipali, for your presentation.
Yeah, thank you, madam.
Next, we have Lavanya presenting an intelligent cyber attack detection and mitigation framework using deep clockwork, recurrent neural network, and deep Q networks. Lavanya, are you present?
Start your presentation, ma'am, please.
I think Lavanya is not present with us right now, so let's move on to the next presentation. Next we have Saksham Mittal presenting blockchain-based evidence management system.
Okay, good morning. Am I audible?
Yeah, you're audible.
Okay, 1 second. Okay, do you see my screen?
Yes.
Okay, so my name is Saksham Mittal from Arya College of Engineering and IT. Our paper title is Blockchain-Based Evidence Management System. One second. So this is the flow that I'll be going through. We'll start with the introduction and the problem we are solving, move into the technologies used, walk through the proposed system and its key features, wrapping up with our conclusion. So digital evidence is now at the heart of almost every investigation, whether it's a cybercrime case, a corporate audit, or a court trial. But the systems used to store this evidence are outdated. They rely on central servers where even a trusted administrator can quietly modify or delete a file. And, well, nobody would know. So logs that are supposed to track everything can also be edited. To fix this, we propose using blockchain, where once something is written, it cannot be changed, combined with SHA-256 hashing to create a verifiable fingerprint. The technology we used is the system is built on a combination of technology such as JavaFX that provides the desktop interface, simple screens for uploading evidence, verifying it, and reviewing the logs, the SHA-256 for the hashing algorithm that converts any file into a unique fingerprint. We use the Polygon blockchain to permanently store these hashes, MongoDB to store the metadata and logs, and Web3j to connect our Java backend to the blockchain. The system is designed to protect digital evidence, as I already stated. The core idea is simple. Instead of storing the actual evidence file on the blockchain, which would be expensive and slow, we only store the SHA-256 hash. The file itself stays on the MongoDB, but its fingerprint is permanently locked. So let me walk you through what makes each technology the right choice. So SHA-256 is deterministic. The same file always produces the same hash. It's also irreversible and collision resistance, meaning no two different files ever produce the result. Because in SHA, even if you change a single character, the entire hash code changes. The Polygon blockchain ensures that stored hashes cannot be altered or deleted by anyone, as blockchains are just ledgers which are not kept at a central server. It's a decentralized system. Each person has its own copy. MongoDB handles the practical side, storing the metadata, uploader information, timestamps, and logs. The system follows a clean layered architecture. JavaFX sits at the front as the user interface, and Java backend handles all the logic, hashing, blockchain calls, and database operation. Because these layers are separate, each one can be scaled or upgraded independently. And MongoDB comes in because we're storing the files on MongoDB. and not on the blockchain. To summarize the core problem, traditional centralized storage allows admins to silently modify evidence, audit logs. This breaks the chain of custody and makes evidence inadmissible in court. Our solution just addresses each of these directly. Any further tampering is instantly detected on re-verification. We implemented this as a JavaFX desktop application with 5 screens: login for secure access, a dashboard, an upload evidence screen where the investigator selects a file, whichever they want to upload. The system computes its hash and sends it to the blockchain. So yeah, web application was basically handled by Web3j and JavaFX. You may ask why this technology, and I told you SHA is deterministic. Polygon blockchain is the industry standard right now for blockchain. Web3j for the interface. Security operates at multiple levels in this system. At the user level, only authenticated users can access the application. At the data level, evidence files themselves are never sent to the blockchain, only their SHA-256 hashes. So sensitive content is never publicly exposed. In our results, the system was tested across multiple file types such as images, PDFs, and text documents, and 100% of the times tampering was detected, and the re-verification was also pretty good. Unmodified files correctly were flagged as safe, whereas the altered files were correctly flagged as tampered. The problem with the traditional systems is just that there's no independent verification mechanism. Logs in traditional systems can be deleted or edited, and they are centralized, whereas blockchain is decentralized. This system obviously leverages blockchain's immutability. To conclude, this research proves that blockchain-based evidence management is not just a theoretical concept, it works. By combining SHA-256, the Polygon blockchain, the database, and a simple JavaFX interface, the system delivers something traditional evidence management has never been able to guarantee, which is independent, verifiable proof that evidence has not been tampered. You can re-verify it anytime and be sure that the evidence hasn't been tampered with. Thank you, and I'll be happy to take any questions.
Hello, dear Mittal sir.
Yes, sir. Yes, sir.
I have seen your presentation, but it seems like a project presentation, not a research paper presentation. Why?
Yes, sir. We actually have a project based on this as well, and we
Okay,
wrote
the project presentation is not a research. If you are developing a research, if you are doing a research, you have to
yes,
show the. Just say, for example, you are saying that the 100% accuracy. How will you
yes,
claim
sir.
that? How can you claim that without showing the procedure?
Yes, sir. Well,
Okay,
100% only on the data set that we gave to it.
just listen to me. Whenever you
Yes, sir.
develop something, then your thing is very best for you. But
Yeah.
you have to show that your system is 100% accurate. Then you have to show the evidence. You have to show the implementation.
Okay.
How will you achieve the 100% accuracy? So this is a missing presentation. So can you explain how can you get 100% accuracy?
So it's basically because we are using SHA-256, where even a change of one character changes the entire hash code that is on the blockchain. So on re-verification, obviously the entire blockchain would collapse because the next connecting block would have a different code, and consequently the chain would collapse.
Saying whatever written in your books, what is written on the literature. But have you any proof? Have you shown?
I mean, it's just on the local data set that we have. Not, I cannot generalize it. You are right.
There is no reference of any research paper. Taking your basically findings without referencing your any citation, any reference paper. How can I say that your system is 100% accurate?
Yes, sir. You're right.
Whenever you do your research and present your paper without any referencing, without any validation, it is useless. Software
Okay.
development is a different thing, but research is a different thing. You have to prove.
Yeah.
So please take care.
Yes.
Thank
Yeah, I'll make sure of that.
Thank you for your presentation. Now we have Suresh Reddy presenting comparative performance analysis of VSI, H5, and H6 transformerless inverter topologies for a 175 kilowatts grid connected photovoltaic system.
Yes, madam. Good morning. Are you hear me, madam?
Yes, good morning, you're audible.
Can I present my slides, madam? Can I
Yes.
share this? Okay. Madam, another participant is sharing, madam. That's why I'm not sharing. I'm not able to share my.
Yes, try again, you'll be able to share now.
Okay, madam. Right now, yes, madam.
Without sharing the presentation, how will I see your work?
Is it visible, madam?
Yes, visible.
Yes. Okay, sir. So good morning to one and all. My research topic is comparative performance analysis of VSI and H5 topology and H6 topology transformerless inverter topologies for 175 kilowatt grid connected photovoltaic system printed by me. My name is Suresh Reddy. Paper ID is 354. Okay, madam. Here, presentation overview. A definition of technical terms, motivation, finding in literature survey, and research problems, scope of the research, papers published and presented, and needed resource and references. Here, definitions of technical terms. What is inverter? Here, a inverter is convert the DC power into an AC power. DC power from PV panels. Integration of standalone applications. Next, transformerless inverter. Here, transformerless inverter gives high efficiency and reduce the harmonics and prevent leakages. Here, this is the transformerless inverter having more leakage currents. That leakage currents to prevent it. Multi-level inverters. An inverter topology that uses multiple voltage levels. It gives multiple level voltage levels and improve the power quality and reduce the harmonic distortion. And leakage current. What is leakage current? Other than flowing in the current wire, it is called leakage current. Total harmonic distortion. To a measure of waveform distortion affecting power quality. It is called a total harmonic distortion. Grid. What is grid? Here, grid is the one standard voltage and standard frequency, standard phase sequence it having. An inverter designed to inject AC power into the utility grid and compelling with grid standards. And H5 topology. A transformerless inverter designed with an extra switch to reduce leakage currents and to improve efficiency. Here, extra switch is DC switch. Okay. Next, neutral point clamped inverter. A multi-level inverter topology that uses diodes to clamp the voltages and improving the power quality. Next, what I motivated in this research in increasing global solar PV adoption demand more efficient, cost-effective, and reliable inverter solutions. Here, traditional transformer-based inverters are bulky, expensive, and less efficient to transformer losses. Why mainly traditional transformer is less efficiency? Why means it having transformer losses. Transformer less inverter improving efficiency, reduced cost, and require advantage leakage current management for safety. Multi-level inverters are needed for high power applications, providing superior power quality and reducing the grid harmonics. Grid stability and reactive power control becoming critical challenges to give PV penetration increasing. Research focus developing inverter design that optimize efficiency, reduce components count, enhance safety, and compare with grid standards. These are the parameters as compared to transformer based inverter and transformerless inverter and mu- and multi-level inverter. Here, mainly efficiency. Efficiency of the transformer inverter having 80 to 95% and transformerless less inverter having up to 98%. Here, multi-level inverter having 96 to 98%. Mostly, multi-level inverters are used for high power applications. Next, the cost is higher in transformer inverter due to transformer is present. Next, transformer less inverter. Transformer less inverter having low cost. Why means there is no transformer in the circuit. Multi-level inverter are also higher inverters. Complex design. Leakage current. Very important point of the this one is leakage current. Minimal transformer isolated ground and can be high in transformerless inverter required to suppression techniques. Minimal in multi-level inverters. Next one. Next, power quality. Power quality depends on total harmonic distortion. Here, a transformer-based inverter, low total harmonic distortion with proper filtering. Next, transformer-less inverter, moderate total harmonic distortion needs additional filters. Low in multi-level inverter, here due to multi-level design. Switching losses, moderate and low and various. And reliability, high reliability and moderate leakage management required, high reliability. Next, finding literature survey. Why I'm taking this? These are the very these are the no one concept to take in the limited peoples are taken this. That's why I'm interested to take this solar panels to solar project. A transformer-less inverter, mainly H5 Herrick flying capacitor, widely used for grid-connected PV systems due to their high efficiency is more than 98%. Multi-level inverters and reactive power compensation and leakage current issues and hybrid inverter technologies and recent advancement include AI-based. Next, research problems. What are the problems I observed in this research? Leakage current management remains a major challenge in transformerless inverter. Multi-level inverter increase control complexity, requiring sophisticated PWM modulation technique. Grid integration requires advanced reactive power management, voltage regulation, and islanding protection. Switching losses and thermal management limited the reliability of high power inverters. Balancing cost, efficiency, power quality in different inverter designs remaining key area. So what is the scope of research? Developing a next generation high efficiency inverters and improved safety features. Here mainly next generation is only solar power. That's why I'm choosing this research. Optimizing transformerless inverters is the one of the main uh, complicated of research. This is that's why I'm introducing this transformerless inverter, enhancing multi-level inverter, designing for high power solars uh, and large scale applications, integrating AI and machine learning for predictive control, and exploring hybrid inverter configuration that combines the benefits of different topologies for high efficiency and power quality, improving inverter grid interaction to ensure compliance more modern grid control standards. What are the need of resources? Mainly, I'm using MATLAB Simulink for simulations, PSIM for circuit analysis, AI and machine learning frameworks for inverter optimization. Computational power is high performance processors. Here, mainly objective. I take 175 kilowatt grid connected PV system module, implementing VSI H5, H6, and H7 transformerless inverter topologies. I want to find what is the best inverter topology for solar PV system model. Analyzing switch behavior using SPWM, sinusoidal pulse width modulation techniques, and evaluating common mode voltage and leakage current and steady grid current quality and harmonic performance. Compare instantaneous active power transform and identify the best inverter topology and for transformerless PV systems. Here, one panel. Modulation specification is 330 watts and maximum power per panel is 31 volts. Current maximum power maximum current per panel is 8.5 amperes. Here, I am using parallel connection. Parallel string is 175 kilowatts. I'm using 20 modules per string. Here, total panel power is 175 kilowatt. Here, clear sky, sinusoidal profile for sunrise, 6 hours to sunset, and 6 p.m. or 18 hours. Superimposed cloud transients is 30 to 90% shading for short duration. Temperature variation from 20 degrees centigrade morning and 40 degrees centigrade to afternoon and 25 degrees centigrade to evening. Here includes small random noise for release. PVDC output. Here, PVDC output generated consideration is irradiance of variation, temperature coefficient 0.4% per degree centigrade relative to 25 degrees centigrade. Daily energy yield calculated via trapezoidal integration. Here, inverter modeling.
Excuse me.
Madam. Yes,
Sorry
ma'am.
to interrupt. This is just a gentle reminder that 1 minute are left for your presentation. So please
Okay, madam.
conclude.
Okay, madam. I'm using LCL filter parameters. Here, these are the parameters of LCL parameters to reduce the harmonics and results. These are the results: PV inputs and PV DC voltage and power, PV DC power and cumulative energy. Here, three-phase inverter, DC to DC converter. That DC to DC converter is given to the three-phase inverter. That three-phase inverter is converted into DC power into AC power. The AC power is given to the grid via filters, inverter pole voltages and pole voltage envelopes and filter outputs and grid waveforms, PV leakage current and grid side currents, common mode voltages and instantaneous active power and current spectrum of phase A. Total harmonic distortion is 13.86%. Here H5 topology. Here these are the topology mode of operation. One set of operation operate at positive waveform and one set of operation operate at negative waveform. These are the H5 inverter topology having 4 switches and one another switch and DC switch is given to the another H5 topology. Next, these are the H5 pole voltages, H5 bridge voltage and filter capacitors and inverter side inductor current and grid current and instantaneous power to grid. Here a harmonic spectrum of grid current is reduced to 6.49%. H6 inverter topology, and these are the pole voltage, common mode voltage, and bridge output, and common mode voltage, PV leakage current, and filter output, instantaneous power, and total harmonic distortion is reduced to 2.41. Next, H7 inverter topology. These are the pulse width modulation, unipolar sinusoidal pulse width modulation legs, and reference H7 auxiliary switches, filter output, grid current, and instantaneous active power. Total harmonic distortion is reduced to 1.61%. These are the parameters of three-phase inverter, H5 inverter, and X6 inverter, H7 inverter. I'm using references.
Presentation quickly.
Sir,
ठीक है. And you are doing. I have seen your paper and your work
yes, sir. Yes,
is
sir.
good, and you have implemented a research base.
Yes, sir.
So you are excellent.
Thank you,
and
thank
I
you, sir.
Thank you.
Thank you, sir.
Thank you for your presentation.
Thank you.
Next, we have Tanveer Ahmed Fahim presenting design of a compact modified insert-fed circular and inverted U-shaped patch antenna for terahertz applications. Tanveer, are you present with us here? Tanveer Fahim, are you present here? We will be moving forward with the next presentation. Our next presenter is Janina Odette Vidalon, presenting Digital Pedagogy in the Age of AI, Opportunities, Dangers, and the Demand for Evaluation in the Broader Domain of Higher Education Provision Online.
Hello, good afternoon. Let me just share my screen. Is it visible now?
No.
Wait. I cannot share my screen.
Try again.
Can you see it now?
Yes, it's visible.
Okay, let me start. So, digital pedagogy in the age of AI, opportunities, dangers, and their demand for evaluation in the broader domain of higher education provision online. So, I am Ms. Janina Odates Vidalion from National University, Philippines. So this is our abstract. Let me read it. This research not only investigates but also focuses on the impact of artificial intelligence on digital pedagogy and the learning and teaching experience at the university level. So our participants are 100 people, which collected their opinions about AI in education through a structured survey. The major outcome showed that people almost universally agree that AI has made considerable contribution to online education by improving its quality, engagement, and accessibility. They consider AI as a powerful tool that accommodates the individual learning pace and style of a student, along with providing unrestricted access to learning, thus making both teachers and learners flourish in the current digital milieu. On the other hand, the study has brought to light a significant set of doubts, such as ethics, the security of personal data, and the apprehension regarding AI's role in reducing the interaction of humankind that are more profound and thus more valuable in classrooms. Most of the participants pointed out that AI may lead to better efficiency of learning process. However, it should never be allowed to overpower the human factor through which education becomes effective in the first place. On the contrary, AI should be seen as a partner that not only assists but also empowers teachers throughout the education process rather than a force taking over their role. According to the study, training, ethical norms that are clearly presented, and awareness programs are indispensable for the responsible implementation of AI. So to sum up, despite AI still being a main factor in the educational revolution, the core of learning will still be human interaction, empathy, guiding, and understanding, none of which can be replaced by any machine. So we know that in today's generation and in today's age, right, we use AI in a lot of things, not just in education field. AI reshapes digital spaces, especially for teaching and learning. Digital pedagogy integrates digital tools with educational strategies. So the advantages is personalization, engagement, and efficiency. And some of the challenges are integrity, privacy, inequality, and shifting teacher roles. Our research questions in this study are: what is the perception of the educators and students regarding the application of artificial intelligence in the digital pedagogy of the higher education institutions' online offerings? And to what extent does artificial intelligence enhance or impede the effectiveness of teaching and learning in digital classroom? What are the opportunities created by AI for personalization, accessibility, and innovation in online education? What are the risks and ethical issues involving the application of AI-driven technologies in digital pedagogy? And lastly, how can the institutions of higher education strike a balance between the advancement of technology and the requirement to ensure that learning experiences are still centered around humans? Our methodology is descriptive quantitative research design. 100 participants, so we have students, educators, and academic administrators. We also use purposive sampling for this study, online Likert scale as our tool, and descriptive statistical analysis for the analysis of data that we have. So these are the results. So I just simplified it. So in the results with our first research problem is AI in digital pedagogy. So the perceptions of educators, students, and administrators are these. So they think that AI improves quality of online education. They increase efficiency and engagement, builds confidence in users as well. Strong belief that AI shapes the future of higher education as we are moving to a more modernized world. For our second research problem is the impact on teaching and learning. So they believe that it enhances lesson delivery for teachers and educators. It simplifies tasks and it simplifies doing instructions and directions for their students. It improves understanding of complex topics. It reduces teacher workload. The technical issues and reduced interaction remain concerns. So there are still challenges and hindrances that teachers perceive with the use of AI, especially the interaction and engagement of students and teachers inside an online classroom. The opportunities provided by AI, personalized learning path. So you could prompt any personalized message or prompt that AI will find for you. The expanded accessibility promotes creativity and innovation, supports self-paced learning, and it encourages flexible lifelong learning. Risks and ethical challenges that the study found. First is the data privacy concerns. So of course, when we use AI in internet, of course, sometimes with our laptop, with our cell phones, sometimes we have issues regarding our privacy, our personal data inside our gadgets. Next is the potential bias in AI systems. Over-reliance may reduce critical thinking. We all know that if we rely to AI and we depend on it 100%, some students and even teachers or other professionals might reduce their critical thinking. threat of reduced human interaction, and need for transparent ethical guidelines. With regards to the results of balancing technology and human-centered teaching, these are the found results. First is AI should complement teachers, not replace them. Emotional connection remains essential. Proper AI training for educators. Students still value human feedback more. And for the conclusion, AI is a powerful tool for modern education. It enhances personalization, efficiency, and engagement, but must be integrated responsibly, of course, and human interaction remains irreplaceable. Some of our recommendations from the study is balance the integration of AI. Let's not over depend on AI. Train educators properly, of course, not just for traditional teachers, but also with the integration of AI. So I think here in the Philippines, we need more trainings on how we should integrate AI in teaching, pedagogy, and in online classroom. Next is promote student awareness and encourage collaboration among all stakeholders. So I would like to end this with a quotation from AI. Artificial intelligence is a compass, not a GPS. It can show you the landscape of human knowledge, but it cannot walk the path for you. Students, the goal is to use AI to augment your curiosity, not replace your critical thought. For teachers, the mission is to guide the hand that holds the tool, ensuring we use these algorithms to sharpen the human mind rather than dull the edge of original discovery. So this came from Gemini AI. Thank you. Hello.
Are there any questions? I think there are no questions. Thank you for your presentation.
Thank you.
Next, we have Suman Dixit presenting Emergency Evacuation Simulation Model.
Good afternoon, ma'am. Am I audible?
Yes, but your volume is like very low.
I'm sorry, ma'am.
You are barely audible.
Hello, am I audible, ma'am?
Yes.
Okay. I'm just sharing my screen. क्या कर रहा हूँ मैं?
Suman, please start soon.
Hello. Should I start, ma'am?
Yes.
Okay. Good afternoon, everyone. I'm Suman Dixit from Arya College of Engineering and IT, and today I'm presenting our research work on emergency evacuation simulation model. So this is the table of content in this presentation. I'll be discussing about the introduction, objective of the research, about the topic, technology used, key features of the simulator, system architecture or methodology, simulation scenarios and configurations, real-time problem statement and solutions, results and analysis, comparative study, and conclusion. So, in critical situations like fires or disasters, safely evacuating people from buildings such as malls, hospitals, and theaters is a major challenge. Traditional methods are often static and fail to capture real time human behavior and hazard dynamics. So, to address this, we developed a simulation model that combines computational techniques to study evacuation in dynamic environments. Just a minute, ma'am. There is some issue in changing the slides. Yeah. So the objectives of the research is to design a simulator that can realistically model evacuation scenarios. So we aim to simulate dynamic hazards like fire and smoke, model human movements using intelligent agents, and optimize evacuation paths. Talking about the topic, this research focuses on computational modeling of pedestrian dynamics during emergency. We use a grid-based simulation where both the environment and human behavior are modeled dynamically. The idea is to create a safe, repeatable, and scalable system that helps us understand how people react and move under emergency conditions. The technology used the technology we used is Java with the Spring framework for graphical interface. We have used agent-based modeling for simulating individual behavior, cellular automata for hazard propagation, and breadth-first search algorithm for pathfinding. Now, talking about the key features of the simulator, it includes real-time fire and smoke spread, eight-directional pathfinding for realistic movement, dynamic path recalculation, collision avoidance between agents, and heterogeneous agents with different vulnerability levels. Now, I'll briefly explain the system architecture. So, the environment grid represents the building layout with walls, exits, and open spaces. The hazard model uses cellular automata to simulate dynamic spread of fire and smoke. For movement, agents use eight-directional BFS with Chebyshev distance, allowing realistic navigation including diagonals while avoiding obstacles, hazards, and collisions. The simulation starts by initializing the map and agent. During execution, agents move towards exits as hazards spread, while key metrics like evacuation count and fatalities are tracked. The figure shows an agent-based emergency evacuation simulation. The left side represents a building layout where colored dots are peoples moving towards exits, obstacles, and hazards. The right panel add hazards like fire or smoke, adjust parameters, and run the simulation. The system uses pathfinding to guide agents efficiently and helps analyze evacuation, safety, and crowd behavior. Now I will explain the simulation scenarios. We design scenarios to represent real-world emergencies by defining the layout, placing agents, and introducing hazards like fire and smoke. During the simulation, hazards spread dynamically while agents move forward, agent move towards exits, and avoid danger. By varying parameters such as agent count, hazard intensity, and map structure, we can analyze evacuation time, congestion, and safety under different conditions. Next, I'll be talking about the real-world statement and solutions. The main problem is that traditional evacuation models cannot accurately predict real human behavior. They ignore dynamic hazards like fire and smoke, do not consider panic, and rely on static plans, which often lead to congestion and higher fatalities. Also, they lack proper evaluation metrics. So, to solve this, we developed a dynamic evacuation simulation model. It uses cellular automata for fire and smoke spread, agent-based modeling for human behavior, and an optimized eight-directional BFS algorithm for efficient pathfinding and with real-time path updates. As a result, our system can simulate real emergency scenarios, support custom maps and hazard setups, and provide both visual and quantitative analysis. The results and analysis show the evacuation is reduced using 8-directional pathfinding as it provides shorter and more realistic paths. Agents dynamically adapt by recalculating paths in real time when hazards spread. We also observe that highly vulnerable agents, especially red category, have the
Excuse
highest
me,
risk.
Simon. Sorry to
Yes,
interrupt.
ma'am.
This is just a gentle reminder that 1 minute is left for your presentation, so please wrap it up.
Okay, ma'am. So we also observed that highly vulnerable agents, especially red category, have the highest risk. Congestion patterns were seen near exits, creating bottlenecks. Overall, the system improves both efficiency and realism of evacuation. When compared to previous models, traditional 4-directional movement results in longer and less efficient paths. In conclusion, we successfully developed a dynamic evacuation simulation model using agent-based modeling and cellular automata. The system improves evacuation efficiency through optimized 8-directional pathfinding and enhances realism with dynamic hazard simulation. It enables accurate analysis of evacuation time, fatalities, and congestion, and supports better safety planning and decision making. That's all, ma'am. Thank you.
Hello, Sejal.
Yes, sir.
How are you?
So I'm good.
Again, I'm talking the same thing. Ki without any evidence, there is no research.
So actually, I've shared the architecture image
No.
of the.
Okay, fine. But you are a beginner, I think.
Yes.
Yes. So next time, with some quantitative data also.
Okay. Sir.
है ना? चलो
Yes, sir.
rest is okay? Fine. है ना? Thank you.
Okay. Thank you, sir.
Thank you, Simon, for your presentation. Now we have Sarah Lutzau presenting Intelligent Continuous Improvement Framework for Ergonomic Risk Mitigation in Automotive Manufacturing using CNN-based risk posture recognition and real-time RULA evaluation. Ms. Sarah Alonso, are you present with us? Ms. Sarah? We will be moving forward with the next presentation. Next, we have Darshika Dudhat presenting multi-object tracking in MOT15 using YOLO version 8 with enhanced PyTrack integration.
Okay, hello. Am I audible?
Yes, you're audible.
Okay. Is my screen visible now?
Yes.
Okay, so good morning, sir. I am Dudhat Darshika, and today I will present our research work on multi-object tracking in MOT15 using YOLO V8X with enhanced bike track integration. Okay, so first of all, what is multi-object tracking? It is a process of detecting and tracking multi-objects across video frame while maintaining consistent identity. It is widely used in applications such as security system, autonomous driving, and crowd analysis. However, it faces major challenges such as occlusion, where object overlaps or disappear. Camera motion, which affects tracking stability, and identity switches, where the same object is assigned different IDs across the frame. So what is our motivation? Despite advancement in detection models, tracking system will still struggle with identity consistency. Existing method often fails in crowded scene during long occlusions where objects are overlapping each other or one object is hidden behind the other object. They are also sensitive to detection errors and perform poorly when the camera is moving. So this creates a need for systems that combine high recall detection with robust association to improve identity preservation. So the main objective of our work is to develop a robust multi-object tracking system that improve both tracking accuracy and identity consistency. We have integrated YOLO V8X detection module with enhanced byte-track framework and focus on handling challenging conditions such as occlusion, dense crowd, and camera motion. We also ensure that system operates in real time, making it suitable for practical application. So we have learned that we have observed that earlier methods like sort method. The sort method is fast, but the problem is it achieved a low accuracy and frequent identity switches. Then there is other earlier method called deep sort. It is improved performance using appearance feature, but still struggled in occluded scenarios where objects are overlapped. But there are more recent methods like byte-track. It improved recall using low confidence detection. And there is also bootstrap method that introduces camera motion compensation. So proposed method to address some challenges like maintaining consistent identity in complex environments. We propose a hybrid tracking system that combines YOLO V8X for detection with robust boot sort tracker for tracking. This integrates ByteTrack's high recall approach with selected improvement from boot sort. The system is designed to effectively handle occlusion, camera motion, and low confidence detection. So dataset. There are many datasets for a multi-object tracking, but MOT50 is the oldest dataset. Now, why we choose this? Because it contains moving and static camera, low resolution video, frequent occlusion, dense crowd, and it contains 11 sequence and over around 11,000 frames. Uh, Importantly, we follow the standard protocol for this. The system is implemented using Python and PyTorch with YOLO V8. Okay, so detection module, as I said before that we have used YOLO V8X for detection and we got high accuracy for detection and we we have used combined ByteTrack and Bootstrap enhanced model for tracking and which has include Kalman filter, IOU plus motion detection, motion-based distance matching, ECC, and EMM. Now, this is our pipeline structure. So first of all, video frame is given as an input. Now, we have pre-processed our image to 1280 cross 1280. We have resized it. Then a YOLO V8X has detected object from the input frame. Then what NMS has done is like it removed duplicate boxes, overlapping boxes. Then we have split that detected objects into high confidence detection and low confidence detection. Then Kalman prediction and matching module, low confidence recovery, camera motion compensation, and REID as a fallback we have used. And then as we can see, MOT outputs. Now, our main contribution for this topic is most of the older method discard the low confidence detection, but we have included low confidence detection because we don't want to we have used this so that we cannot miss any smaller object also. So evaluation metrics, we have followed a standard metrics. Here it is a multi-object tracking accuracy. It measures overall tracking accuracy, while IDF1 evaluates identity consistency. Precision and recall measures detection performance, and identity switches indicate tracking stability. So here is our qualitative result, as we got MOTA around 55.6%, which is very remarkable accuracy in MOT's 15 benchmark. Then we have got very high recall, about 95.7%, which means that we have covered almost all objects for detection. This is a result from our output. As we can see the output, the most of the objects are detected by our system. Limitation, as our Kalman filter assumes that the input frame has a constant velocity, so it may struggle in complex motion. And also we have a limited to tracking a pedestrian only. So our future work is we will work on multitask tracking and we'll learn more advanced motion models. So to conclude that, I want to say that we propose a robust multi-object tracking system that improves both accuracy and identity preservation. By combining YOLO V8X with enhanced byte framework, we achieved a strong performance along with real-time capability. These are some reference from my research paper, and yeah, thank you, sir.
Can you show me the references, please?
Okay, sorry.
Darshika?
Yes.
Darshika, you have done a good job, and keep
Okay,
it up.
thank you, sir.
I just say keep it up, and I just want to know that in which ratio you have split your data set?
Like 60-40.
Why?
There are 11
why not 80-20?
sequences.
Why not 70-30? Why not 75-25? Is there any performance issue?
No, but we have observed that for training, this ratio is good. We got advised from our mentor. So.
But when you train the data with the higher ratio, then it will give the better result. High training, high accuracy.
Oh yeah.
No. Next time. Thank you so much.
Okay.
Good work.
Okay.
Okay.
Thank you, sir.
Next presentation.
Thank you for our presentation.
Yes.
Next
good morning,
have,
everyone.
Just let me introduce you, then you can go ahead.
Hello.
Now we have Rupesh Kevan Sungar presenting predictive optimization of energy consumption in smart building through AI Gen scenarios.
Okay, so greetings, everyone. Are you able to hear me correctly?
Yes.
Okay, so I will share my screen. Are you able to see the screen being shared?
Yes.
Okay, so I will talk a bit on the research which was used to use AI to come up with predictive scenarios for the modeling of energy consumption. So the research is predictive optimization of energy consumption in smart building through AI-generated scenarios. So the problem statement is that smart buildings with IoT devices and energy consumption optimization remains a challenge because we are using IoT devices a bit everywhere, but still coming up with this smart building and doing some kind of predictive modeling of the energy consumption is something that is challenging. So we have large volumes of sensor and devices data, and that creates a complex environment for energy management. So to be able to extract actionable insights from diverse data sources is challenging because what is happening actually is that we are kind of overloaded with data. So combining domain expertise with advanced data analytic techniques is interesting, and this is the purpose of this research. So as aims and objective, we have been working towards implementing a predictive optimization technique using artificial intelligence. And in terms of objective, we have been analyzing current energy consumption. We have been exploring AI simulations, and we have been developing predictive optimization model. So the scope is we've been analyzing a lot of energy consumption patterns, especially nowadays. We know that energy is quite a sensitive topic, bearing in mind what's happening in the Middle East. So being able to have some kind of really accurate energy prediction model is something that's going to be important. So exploring of AI techniques for predicting and optimization, developing our predictive optimization model. So in terms of research gap, what we have identified was advanced AI for energy prediction, because we've seen that traditional methods miss complex interaction. So all of these traditional methods and how they miss complex interaction were thoroughly explained in the paper that was submitted. So IoT data integration is underused, a need for adaptive model for different buildings. So our solution was to use AI to create realistic scenarios, improving predictive models. So in terms of methodology workflow, we have had some data collection, some data pre-processing, data visualization, using feature selection analysis. And then we implemented the AI model. We've been evaluating the AI model. We've been selecting, because here I will explain in the next slide that we've been choosing a number of algorithms for the AI model, and we have identified the one that's performing best. So model selection, generative scenario and prediction, and result visualization. So a bit of the equipment that we've used, on-site installation. So these are IoT energy meters. A brief of the architecture. So we have our IoT server, the LoRa gateway, LoRa node, energy meter, and device. So we've been collecting data. Just a very brief slide on the data that was collected, the daytime, the administration AC, light, energy engineering office, light, main CB. So a number of data that was collected here. We have been collecting and tabulating the data as here presented. We have the model that was selected, and we've been carrying out a number of algorithms. We've been using a number of algorithms, and we've tried to identify, for example, the one that is performing best. Some we've been testing the model with gain neighbors, random forest, gradient boosting, XGB. But the one that performed best was MLP regressor. So this one performed best, and we've observed that for such kind of research where you would be generating AI scenarios, this for energy consumption, the MLP regressor performed best. So in terms of function, we have inputs, features, prediction, outputs. So in terms of output, we've been having like 107,860 scenarios that were generated using AI. we have our software that was developed whereby it's easy to use and it has a web-based interface. We've been having some results where we compared the actual monthly consumption with the predicted energy consumption. So you will find that the error margin is not that very much. So this is where we evaluated the system in terms of percentage of errors of a prediction. So this was quite low, and we would say that our model that was proposed was quite accurate. So as a conclusion, we can say that the AI model that was proposed was of high accuracy. Model provided some model adaptability. It has this economic and environmental benefit because of low carbon footprint. This is in line with the energy efficiency strategies of the Mauritius, because I'm from the University of Mauritius, and we're working with the government in terms of trying to identify certain strategies so as to optimize energy consumption in Mauritius. So this is more of a practical solution, and it can provide a framework for future research. So thank you for following the presentation. So any question you might have?
No, thank you. Next presentation.
Okay, thank you.
Hello.
Hello, is this Sarah?
Yeah,
Yes, Sarah, I'll introduce you, then you can present.
yeah, thank you.
Now we have Sarah Luxel presenting Intelligent Continuous Improvement Framework for Ergonomic Risk Mitigation in Automotive Manufacturing using CNN-based risk posture recognition and real-time RULA evaluation.
All right, just 1 minute. Do you see my screen? It's okay?
Yes, it's visible.
Yeah. Thank you. So good morning, everyone. Sorry, my name is Sarah. I'm from Morocco. I'm living in France. And I'm pleased to present my research today at ICTIS 2026. So my work focuses on ergonomic risk prevention in the automotive industry, where I'm working for the moment, which is a challenge for both worker safety and industrial performance. So in this research, I propose an intelligent framework that combines artificial intelligence and ergonomic assessment to enable real-time decision making on the shop floor. In the automotive industry, we say musculoskeletal or musculoskeletal disorder or MSD disorders remain one of the most common health issues or health problems. They are mainly caused by repetitive movements and non-neutral wrist posture during manual tasks or artisanal tasks in automotive industry. Wrist posture is particularly critical as a prolonged exposure to complex position can lead to long-term injuries and work accident. So traditional ergonomic methods such as RILA are based on manual observation. It's a scoring methods and very classic done by ergonomics people or specialists just by observation. So these methods are subjective and periodic, which means they do not capture continuous exposure on subtle position variation. This creates a gap between real working conditions and risk evaluation, highlighting the need for a more objective and real-time approach. So, to address these limitations, I propose an AI-based continuous improvement framework. The system uses a conventional neural network, CNN, to classify wrist postures into acceptable or okay and non-acceptable or not okay categories. This classification results are then integrated in the RULA methods to evaluate ergonomic risk levels. This allows us to transform visual data into standardized and interpretable indicators and KPIs. The system operates in real time, enabling continuous monitoring and proactive intervention instead of reactive correction. So we are going from the corrective with the observation or human observation done by the ergonomic expert to the prevention and the proactive. So this slide presents the overall system architecture. The process begins with data acquisition using image or video streams captured in a real industrial environment in the workstation of the operator. Then processing is applied, including ROE or a region of interest, which is in this case the wrist, including the region of interest extraction focusing on the wrist and normalization of pixel value depending on images. So the CNN model performs a real-time classification of wrist posture. The results are then converted in RULA scores to generate ergonomic risk indicator. Finally, the system supports decision-making through alerts and continuous improvement actions, such workstation adjustment or task design. This architecture is designed to be modular and scalable for industrial deployment. The core of the methodology is based on CNN-based wrist posture classification. The model makes difference between acceptable and non-acceptable wrist postures. The data or the data set used for training was collected in real time or in real industrial conditions to ensure realism of the methodology. Data augmentation techniques were applied to improve robustness to variations such as lighting, movement, and viewing angles. So one key point is the ability of the model to handle borderline postures, which is often difficult to assess even for human experts. In addition, the model performs real-time inference, which allows continuous monitoring during task execution. This slide presents the experimental setup used to validate the proposed system. The experiments were conducted in a real automotive production environment involving manual and semi-automated automated tasks. A non-intrusive camera setup was used, allowing operators to work naturally without disruption. The dataset includes 3,000 labeled images with 1,500 acceptable and 1,500 non-acceptable with posture. All data was manually annotated to ensure reliable growth truth. The model was evaluated using standard performance metrics such as accuracy and confusion metrics, allowing us to assess both reliability and practical applicability of the method. The results confirm the effectiveness of the proposed approach. The CNN model achieved an overall accuracy of 92% with 2,760 correct classifications out of 3,000 images. The confusion matrix shows strong reliability with a correct detection of 1,395 acceptable and 1,365
Excuse me,
non.
Sarah.
Yeah.
This is just a gentle reminder that 1 minute is left for your presentation, so please wrap it up.
Sorry.
1 minute is left for your
Okay.
presentation, so please wrap it up.
Okay. Sorry. I will be quick. So this system is able to detect subtle and repetitive risky posture, which is often overlooked in traditional assessment. And for conclusion, this work proposed an AI-based framework for continuous ergonomic task prevention by combining CNN and rule scoring. And it enables continuous monitoring and supports proactive actions such as workstation improvements, as I said. And from industrial perspective, this contributes to both operator well-being and performance improvement for the employee and the employer. In addition, the approach supports lean continuous improvement and aligns with Industry 4.0 principles. And as a future work, the system can be extended to other body parts and more complex industrial scenarios. And thank you so much. I'm sorry for being too long.
Sir, do you have any questions?
Hello, Sarah.
Hi.
How are you?
Fine, and you?
I want to ask you two questions basically. One question is that you are finding the posture, okay or not okay. Now, if the images blur or dim in light, then in this situation, how will you handle this image?
For the first question, you asked me why we did okay, not okay.
No. My question is that if the images blur or some problem in lightning, then how will you handle the situation?
Okay, in the database of image, I took in consideration a different problems like lighting, angle viewing, orientation. We have even deformed some image to try to give realism conditions of pictures because the shop floor is not also lighting, it's not also without visibility problem. So the data set, it was constructed to take in consideration all this type of problems, visibility problems of image or video.
My second question is that you have total 300 images.
Yeah.
And have you applied data augmentation?
A little bit data augmentation.
Not little bit. Yes or no?
Yeah. See, we cannot take 300 from the shop floor. Yes.
And what is your data set split strategy?
Sorry.
Have you created a confusion matrix?
Yes.
Yes. Then you have applied the data set split strategy. You divide the data into test and train.
Yeah, 1,500
No,
both for
I want to
Okan.
know
Okay.
that. What strategy you have followed.
Sorry, I did not get your question.
Okay. You have 3,000 data set, 3,000 instance images, है ना? Yes or no?
Yeah.
Yeah. Then how much images is used for training and how much images used for testing and how much images used for validation?
70%, 30%.
Why not 80-20?
Sorry?
Why not 80 and 20 ratio?
It was a recommendation from my PhD supervisor, so we did it like that. Maybe it's a possibility, it's an alternative too.
That is fine. Have you tested?
Yeah, it's already tested. The last image that you see, it's from the final output of the work. So if you can see here, we have, I have done a biomechanical detection with Yola, with applications already done of AI poster detection,
Okay,
and
thank you. Thank
and
you,
I have
Sarah.
included wrist with CNN, and there is a result with the green color here.
Thank you, Sarah.
Thank
Excellent
you
work.
so much.
Thank you, Sarah, for your presentation. Next, we have Lavanya presenting an intelligent cyber attack detection and mitigation framework using deep clockwork recurrent neural network and deep Q networks. Lavanya, are you present? Lavanya? Okay, that's it for our presentations today.
Only one presentation is left of Lavanya. Yes?
Yes, sir.
All presentation have been completed?
Yes.
Okay,
And I think,
except Lavanya.
yes, and I think Lavanya is not.
I'm waiting for 5 minutes. Just coordinate if possible, then inform her.
Okay, so we'll try that. We'll wait for 2 minutes. If she doesn't show up, we'll conclude the session.
Okay, thank you. Please conclude the session. No? Thank you.
Yes, sir. And with that, we are done with all the presentations for today. I sincerely thank all the authors for the excellent presentations and valuable contributions. I also extend my gratitude to all the participants for being a part of this conference. I hope this session has been informative and enriching. On behalf of the organizing team, thank you for your continued support for ICTIS over the years. We look forward to welcoming you again at the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication process will be completed within 7 to 8 months. Kindly extend your cooperation to the ICTIS 2026 team during this period. I would also like to thank our session chair, Dr. Vipin Khatri, for chairing this session today. And as a token of our appreciation, we present this to you, sir. Would you please like to share any closing remarks with us, sir? Sir, are you there with
Huh.
us?
What are you saying?
Sir, would you please like to share any closing remarks?
I just want to say for every researcher, please do some quality-based research. If you want to do survey research, then you have to deep dive into the survey literature. So, and most of the paper should be in implementation form. So it will increase your credibility. Whenever you go for an interview or you go for a selection, then they will see the research aspect. So if your research is good, implementation based, then they will recognize. Otherwise, they ignore the CV. So please, my humble request, please do the quality research, please. Thank you all.
Sir, just 1 minute. I think Lavanya is present with us here.
If
Dr.
she is here, then
Yeah,
say to her, please present.
yes. Dr. Kiran, you have messaged in the chat box. So are you going to be presenting on Lavanya's behalf?
Madam, Lavanya is present, but due to some network issues, we are just changing that laptop. That's why. Within few minutes, she will come.
Can you
No
please?
issue. I will wait. No issue. I will wait.
Can you please can you give some other slot for Lavanya, madam, for 15 minutes or 20 minutes later? Hello?
Yes, I heard you. Listening to.
Madam, after 1 o'clock, she will come, madam. That's why. If you give another slot, then she will easy to give the presentation. That's why.
Okay, let us see what we can do if we can arrange it in the next session. For
Okay,
now,
madam.
just ask her to send her presentation at ICTIS Thailand support email, and then it will be considered.
We have to send the PPT to that particular mail ID.
Yes.
Can you please give the mail ID, madam, once again?
It will be put in the chat box.
Okay, ma'am. Okay, thank you. Within 2 minutes, 5 minutes, she will send, ma'am.
Okay.
Okay.
Okay, thank you, Sanskriti.
Yes, sir. Now I request everyone to turn on your camera so that we can have a quick snapshot of the session. Thank you everyone for joining us today. I hope you all have a great day.
Thank you. Okay. All the best for everyone.
Thank you. Bye, everyone.
Thank you.
Thank you. Bye, everyone.